On 13.1, we're going to talk about the right triangle trig stuff. So I'm going to put over here a nice right triangle, where I got the 90-degree box in there. And then I'm going to use this symbol right down here. Does anybody know what that Greek symbol is? Theta, which stands for angle. Okay? Now, for this particular thing, depending on wherever the angle is at, this side from the angle would be the adjacent side. This side would be the opposite side. And this one that's across from the 90-degree corner is always known as the hypotenuse. Now, the trig ratios that I'm going to go through with you guys are not different. They're the same things. We even talked about one a couple days ago. We talked about sine, cosine, tangent. Right? SOHCAHTOA. Didn't we do that in one of those tests? Practice ones? Right. The sine ratio, or the sine of theta, is equal to the opposite side divided by the hypotenuse. That's the first one. The second one, cosine. Anybody remember what cosine is? Adjacent over hypotenuse. And the last one, or the big three anyway, tangent. Opposite over adjacent. Very good. Ooh, can't spell adjacent today. Okay? So those are ones that you guys should have seen before, right? You guys seen those in your algebra or in your geometry class last year? Those of you who had geometry from me last year, I know you did it. It was towards the end, but we did it in that particular context. There are 3 new ones, though, for you that you have not done before. Okay? And what they are, basically nothing more than me just flipping them over. The next one that I'm going to go through with you is called the cosecant. It's abbreviated as CSC.
Yeah, I saw this yesterday.
Okay? The cosecant is the hypotenuse over the opposite. It is the reciprocal of the sine function. Okay, that's all it is. Just flip it over. The secant is the next one, which is the hypotenuse over the adjacent.
Is that CSC?
Yes. And the last one, the cotangent, is adjacent over opposite. So if you take a look at those, if they say what's the secant, cotangent, or cosecant, they are nothing more than the reciprocals of its partner, the sine, cosine, and tangent curves. Okay? So if I have a ratio, for instance, of a sine being 1/2, if I want the cosecant, all I do is flip that 1/2 over. What's the reciprocal of 1/2? 2. Okay? That should have been turned in last week when we went through it. Goofball. All right? Is everybody okay or have the ratios down? Because that's, for the most part, everything that we got going on today. There's a couple more different ones on there where they talk about the cosecant itself being equal to 1 over the sine function, or sine. And they do the secant as being 1 over the cosine. And the cotangent as being 1 over the tangent. Now, just so that you guys are aware of that notation that I just put there, that means nothing more than just the reciprocal. Okay, so if I say, like if I had the sine curve to be, or sine ratio to be 3 over 4, the cosecant would be 4 over 3. All I got to do is just write the reciprocal. Okay? Then on the bottom of page 853, they give you some right triangles that were special. I know in the one geometry that we had last year, some of you with me, it was chapter 8. We had special right triangles, the 30, 60, 90, and the 45, 45, 90. Do you guys remember those? Those of you who didn't have me? If you are a 30, 60, 90 triangle, there are some certain ways that you can get around this. If that's the short side is always across from the smallest angle. And what I would do is I would take the short side multiplied by 2 gives me the hypotenuse. So the hypotenuse is going to be multiplied by 2 to whatever the short side would be. Okay, so if that short side is 4, how big is the hypotenuse? 8. Okay? Then in order to find the medium side in this one, I'm going to take that short side and multiply it by root 3. That's how the pattern works. Okay, in a 30, 60, 90 triangle, the medium side, or the longer leg they refer to it as sometimes, it's going to be take the short side and multiply it by root 3. Now, if I give you that medium side, to work backwards to find the short side, then you divide by root 3. Okay? Just so that you remember that. Then, if I have one of these triangles that is a 45, 45, 90, these two sides are always going to be the same. Because a 45, 45, 90 is an isosceles triangle, and if you don't remember that, isosceles means it has two sides and two angles the same. In order to do the shortcut, you could do x times the square root of 2. That's the shortcut. If you don't like the shortcut, especially with the 45, 45, 90, you could use the Pythagorean Theorem and go x squared plus x squared equals blah squared, and then figure it out, and it's the same, it's the same answer as x times the square root of 2. And that's what they have down there for the special angles at the bottom of page 853. They give you a chart for every single one of the sine, cosine, tangent, cotangent, cosecant, and secant functions for those special triangles. Okay, they give them to you already if you want that chart. All right. Then from here, that's pretty much all that's going on, except for now it just wants you to tell me the different pieces. If you go to page 856, I'm going to do some of the ones right out of your assignment, where it gives you, on number 3, $10 here, 24 here, and theta is there. Okay? It says evaluate the 6 trig functions of the angle. So, I got the sine, I got the cosine, I got the tangent, I got the cosecant, I got the secant, and I got the cotangent. Those are the 6 that they want you to tell me. Now, here's the problem with this thing. One of those pieces is missing, is it not? What piece don't you know? No, I don't want to know the angle. I don't know the hypotenuse. How do you find the missing side of a right triangle? Pythagorean Theorem. A squared, 10, plus b squared, 24, equals c squared. What's 10 squared? 100. What's 24 squared? 576 plus 100 is what? 676. Is it perfect? Okay. So then when I square root that as, I know that to be 26. Okay, so as far as sine goes, okay, and that's how I had to find, got to have all the different pieces first, which we did. Now the sine. Sine is the opposite side over the hypotenuse. So what's the opposite side from theta? 24 over 26. Can 24 over 26 reduce? Yeah, down to what? 12/13. Good, that's the sine curve. Hey, guess what? Let's find the cosecant right away too. Flip that over. What do you get? 13 over 12. Cosine. When I'm doing the cosine curve, I'm doing the adjacent side over the hypotenuse. So what's the adjacent side to theta? 10. over 26, which reduces down to what? 5/13. So let's do the secant right away. 13/5. And then to do the tangent, I do opposite side, 24, over the adjacent side, 10. What's 24 over 10 reduced to? 12/5. And if I know the tangent, how do I get the cotangent? What's 12/5 flipped? 5 over 12. Okay? So, to do the 6 different ratios really doesn't, once you find the first 3, all you got to do is write the reciprocal for the next 3. Okay, does that make sense how I did that? This is how you're doing the entire thing, by the way. And that's just the first part up there. But the rest of them, when it says for 9 through 14, it says let theta be an acute angle of the triangle. Find the values of the other 5 functions of theta. Okay? Caleb, pick a number between 9 through 14. 13? No. We just did that one. 12? 12 has, what's CSC short for? CSC was short for cosecant. Cosecant function I gave you as what over what? 1 over the sine, or the reciprocal of the sine, right? So the 10 in this case is the hypotenuse, and the 7 in this case would be the what? Opposite side. So here's what I do. All I do is I pick an angle. So I'm going to put theta down here in the corner. And if I know that it's CSC like that, 7 being the opposite side, that means I put 7 here. And the hypotenuse was 10, I put 10 here. Now, how do you find the missing side of a right triangle? Pythagorean Theorem. A squared plus b squared equals c squared. This time, you know c, don't you? So if I had 7 squared plus I don't know squared equals 10 squared. What's 7 squared? 49. Plus I don't know squared equals, what's 10 squared? 100. I want to get b by itself. That's my goal. So what do? Subtract 49. What's 100 minus 49? 51. And when I square root that, just so that you guys are aware of this, the square root of 51 breaks down into 3 times 17. Is there a pair of numbers there that's the same? No. So it remains the square root of 51. Now here's where it's going to get interesting. Here's where it's going to be more work for you. It said, I gave you the cosecant. I want you to find the other 5. That's what the direction said, yes? So I need to know the sine. I need to know the cosine. I need to know the tangent. I need to know the cosecant they already gave us was 10 over 7. I need to know the secant, and I need to know the cotangent. Those are the other 5 that they want you to find. Now the sine will be easy, I think, because all I have to do is do what to the cosecant? Flip it over. What's 10 sevenths? The reciprocal of it. 7 tenths. That one, I think, would be pretty easy, right? Okay. Now, as far as cosine go, the cosine of this thing was the adjacent side over the hypotenuse. What's the adjacent side to theta? Square root of 51 over hypotenuse of 10. Here comes the bad part. When I write the reciprocal for the secant, I can't have square root in the bottom. So then I'd have 10 over the square root of 51, but I can't leave it like that because the square root of 51 cannot be in the bottom of the fraction. So what do? multiply it by the square root of 51. So I'm multiplying it by itself. So I end up with 10 root 51 over 51. Okay? Now, I know I kind of ran out of room there, and I apologize for that. But that said 10, the square root of 51 over 51. If you can reduce the outside numbers, so like the 10 and the 51, then go ahead and do it. But if you can't, like this one, leave it alone. All right, tangent. What's the opposite side to the theta? 7. What's the adjacent side? Square root of 51. And I run into the same problem I had on the last part. Can I have square root of 51 on the bottom? No. So I multiply it by both the top and the bottom. So I get 7 root 51 over 51. Can I reduce 7 over 51? No. Good. Now cotangent. What happens if I flip it over? Now, try to keep this in perspective. This is the answer I got when I reduced it. But don't flip this one, because then you're making way more work than what it's worth. Flip the original one. Because in that way it's already done, right? Because then the square root would be on the top. So I'd have the square root of 51 over 7. Instead of having to square root that, or flip it and then have to square it or times it by itself again, and you got a big mess. Okay? What do you think so far? Some of these are going to be a little bit more work than what you think. Then, on 17 through 19, it says find the exact values. Not decimal values like some of you are doing, but exact values. Mr. Doctor, since I got to see you for 4 hours yesterday, would you pick a number between 17 through 19?
Let's just go with 17.
17? Nick, do you know what kind of triangle that is?
Just a right.
More specifically?
Oh, 36 to 90.
How did you know it was a 30, 60, 90?
It's on 90 and 60.
Because you saw a 90 and a 60. Right. So the other one has to be 30. Now, Nick, one last question for you before I leave you alone. The 8 that I wrote up there, is that across from the short angle or the medium size angle, or is it across from the 90 degree angle making it the hypotenuse?
What, the 90 degree?
Is the 8 across from the smallest angle, medium sized angle, or biggest angle? It's across from the short one, which would make that the short side. Okay? When it's across from it like that, that's the short side. So, if I gave you a short side of 8, to find the hypotenuse, I would multiply it by 2. Fallon, what's 8 times 2? Yeah. So y is equal to 16. That one was pretty easy, wasn't it? Okay? Now, to get the medium side, you take the short side and you multiply it by the square root of 3. Fallon, do you know what 8 times the square root of 3 is? Oh, very good. 8, the square root of 3. Nice job. Thank you. Okay? A lot of people try to multiply that out on the calculator, but when it says exact values, Fallon gave me the exact answer. Because the square root of 3 is a number that continues on. It's irrational, so it's never going to stop. So there's number 17. That's what you'd have to do for those. On 21 to 28, on those type, it says solve triangle ABC using the diagrams in the given measurement. So it gives you this picture, where it says that this is A, this is C with the 90, this is little b, this is little A, that's little c, that's big B. Okay? Liz, would you do me a favor and pick for me one problem out of there? Hello? Yep. Noah. Counselor. You're the only Noah. 26. So what they gave you for there, Liz, thank you, by the way, for picking that one. It gave you big A as being 49 degrees. And it gave me little c is equal to 27. Okay? Now, what they mean by finding or solving the triangle, they want all three sides and they want all three angles. That's what they want. So angle A, Liz told us was 49. Angle B, I don't know yet. Angle C was 90. How big is angle B? 41? How'd you get that? Huh? 90 minus 49. Okay. Good. Everybody okay with that so far? Now, I need to find little a. I need to find little b. And I got to find little c, which is 27. So now, here's where you use your sine, your cosine, and your tangent. That's what you got to do. So, which angle do you want to use? Do you want to use the A that they gave you, or do you want to use it going from B? You make the choice. It doesn't matter. A. If I go from angle A, which is right here, and if I want to find little a first, is that side across from it, so it's opposite, or is it adjacent to it? It's an opposite of the 49, right? And the side that they gave you, was that the hypotenuse, or was it one of the other two sides? So which one deals with opposite and hypotenuse? Sine does, right? So the sine of 49 degrees equals, I don't know, divided by 27. Now, in case you're wondering on how that works out, what you're going to have to do is, this is nothing more than a ratio, and you cross multiply and you solve for a. 1 times a is a, and then I end up taking 27 times the sine of 49. Now, with your calculators, there's something that might be an issue. I want you to make sure on your graphing calculators, before you type anything, I need you to hit the mode button. And down around the third line down, we should be in degree mode, not radian mode. Okay? Because we're dealing with degrees, not radians. We'll deal with that later on this chapter. Make sure you're in degree mode. If you're using a scientific calculator, just a basic one, those are usually in degree mode to start with. Okay? So if I'm in degree mode, okay, then I type 27 sine of 49, enter. What do I get? Yep. So 20.4. Okay. If I round to the 10th place? Okay, good. Now how do I find little b? One of the ways I could use it is I could use it doing the Pythagorean Theorem, like Fallon said. The only problem with that, Fallon, I'm not going to use the Pythagorean Theorem here. The reason why, that 20.4 was a rounded answer. It wasn't an exact one. So I'm going to try to bypass that one just because that 20.4 was rounded. It wasn't exact. So I'm going to use cosine or tangent instead. And in this particular thing, I'm going to use, if we're still going from here, side B was adjacent to it, side C was opposite or hypotenuse, so that's the cosine. So I got the cosine of 49 equals the B over the 27. And I set it up the same way. 27 times the cosine of 49. How big is the side? What did you say, Denise? 17.7. Thank you. Now, something that I want you to understand, and hopefully you guys get this. Side B should have been the smallest side. Why did I know that? Because it's across from the smallest angle. Side A should have been the medium side. Why? Because it's across from the second biggest angle. And side C should have been the hypotenuse, or the longer one, because it's across from the biggest angle. If it doesn't work out that way, you screwed up somehow. Okay? So, that's how you do the last ones. So the first few, you're finding all the pieces. The last little bit there, you're finding the pieces that are missing. There are 6 parts to a triangle. That's why you had those things called CPCTC last year. Right? So on page 856 to 857, we're going to go 4, 28, evens.